So we want to make sure we have a good visual idea and a sense of how much proportions and percentages are. So when we look at 78%, we can think of it as, 10, 20, 30, 40, 50, 60, 70, and then we can have 1, 2, 3, 4, 5, 6, 7, 8. That represents 78% of that hundreds grid. In this case, we can do 3/4. It actually says also do as a fraction and a ratio, so we need to convert this into a fraction. So we have 78 out of 100 as a fraction. We should simplify this, and we divide by 2, we get 39 out of 50. As a ratio, we can just write this as 39 to 50 ratio. Okay, so fraction and ratio are essentially the same thing. When we do 3/4, we can do 3/4 as a percentage. Okay, 3/4 is going to be 75%. We can do 3 divided by 4 and then times it by 100. As a decimal, it's going to be our decimal percentage, okay, which is also what we are going to call our unit rate. Okay, that's our up and down multiplier. As a picture, we could draw in, we could shade in 70, 10, 20, 30 like that. But since 3/4 should be one of our benchmark fractions, we can draw 3/4 by drawing in 3 parts out of 4. Instead of thinking of 75 out of 100, we can think of it as 3 parts out of 4 parts. So we're going to shade 1, 2, 3 parts out of the 4 parts, and that represents 75%. Okay, so we should make sure we have that connection that 75% is related to one of our benchmark fractions of quarters. So here, if we have 30% off, what percent are we paying? Well, the 30% off we can represent as these 3 bars. Okay, we can say that that's 30 out of 100. And that's what we're not paying. So the part that we actually do pay is going to be represented by these 70 squares, okay, or 70 out of 100. Okay, so we are paying 70%. That's how much we're paying. Okay, as a fraction, we're paying 7/10. We pay, and 3/10 represents our discount. Okay, so it's important that we have these fractional pieces of the parts of paying parts, discounts parts, because again, if we can express these in a fraction, we have our times, divide, multiplier pieces. Okay, and this is going to help us with our calculations. Okay, so how do we convert these from fractions to percentages? Well, 2/3 as a percentage, we're just going to divide. We get 0.66 repeating. Okay, as a percentage, we can write it as 66.7% when we round it. Okay, we can make sure that we understand this as a proportion. It's going to be 2 to 3 as to x to 100%, x% to 100%, part to whole, part to whole. Okay, and here's our decimal multiplier of times 0.66 repeating, and that's the same multiplier that we'll use on the other side. Okay. 2/5. Okay, we can start with our proportion this time. So we have 2 out of 5 is going to be x% out of 100%. Okay, we can use a multiplier of times 20 going from left to right. We have our up and down decimal multiplier, which is our percentage, multiply our decimal percentage multiplier. Okay, that's 0.4. Okay, that 0.4 represents 40%. Okay, so this is 40%. Okay, so we can divide and come up with our decimal multiplier and convert to percentage. Make sure we can put it in a proportion. Okay, so 32%, we're going to write it as 32 out of 100. Okay, and we can write it as a reduced fraction. Okay, we can divide by 4, and we get 8 out of 25. Okay, so same thing here, we can do 230%. Okay, or 230% out of 100% whole. Okay, and we can simplify this. We have common factors of 10, so it becomes 23 out of 10, okay, as our fraction. And our decimal multiplier is going to be 2.3, which is our decimal value for that fraction. Okay, so solving these percent problems, again, I want you to make sure that you understand how to set up the proportional equation. Okay, we're comparing our percentages here. Part to whole is part to whole. Okay, the multiplier up and down, that decimal multiplier is our decimal percentage. Okay, it is also our unit rate. Okay, so there is also this left and right multiplier that we could use of times 2.5. Okay, but either way, okay, multiplying by 2.5 we get 75. I can divide or I can multiply 250 with 0.03. In either case, we get a value of 75. So 75 out of 250 is same as 30%. Okay, so again, there's two different ways we can do this. Okay, so same thing here. We want to set this up as a percentage. Okay, so 76% compared to 100%. And again, I expect you to be able to set this up and show me the ratio, the equivalent fraction ratio for this. And 38 represents the part, and then x would represent the whole. Our decimal multiplier in this case is going to be our decimal percent. Okay. Now we're going, instead of going from bottom to top, we're going the other way around. So we're going to have a divide by 0.75. Okay, so we end up with x equals, okay, so the 38 divided by 75%. Okay, that's, you need a calculator for that. Okay, so we're going to do 38 divided by 0.75, and that gives us 50.66. Oh, sorry, that's going to be 0.76, isn't it? Okay, so 0.76, that divides nice and evenly. X is equal to 50 exactly. Okay? So when we're doing this, we could also set this up as a times divide problem. So we can say that 38 is the part, and then we can say that we want the part, the whole. Okay, so we can say the 100% whole over the 76% part. You can see how the divide by 0.76 now shows up. Okay, top is times, bottom is divide, so we can, those times and divides cancel out, and we're going to end up with 50 as our whole. So this is an alternative method that we're going to start using a bit more, this idea of multiplying in multiplying by our ratios. Okay, and as long as we understand how the ratios cancel out, the units cancel out, we can see that we have the ratio in the right way around. And the question really ends up being, do we divide by that percentage or do we times by that percentage? And that helps us solve that problem of keeping track of that. All right, so the Whitecaps had 67% of the ball possession in the soccer game that was 90 minutes long. So we have 67% out of 100%. Okay, and it's going to be, the total is going to be 90 minutes, and we're going to look for the part. Okay, so again, our multiplier here is going to be times by 0.67, and we're going in the same direction, so we're going to times by 0.67. Okay, so we end up with 90 minutes times 0.67. That gives us 60.3 minutes. Okay, so the Whitecaps had 60.3 minutes of possession during this game. Okay, so for this one here, Jason gets $200 off a computer that was 30% off. What was the original price and what was the sale price? Okay, so we can set this up in a few different ways, but we need to make sure we understand what our comparison is. Now this is our discount. $200 is our discount. 30% is their discount. They kind of go together. Okay, so that's discount compared to discount. Okay, so I'm going to set it up like this. I have my 30% is my part, and then $200 is also my part. I know that that's going to be compared to 100%. Okay, 30% to 100%. And then this represents my original 100% price. And again, I can use my 30% multiplier if I want. Okay, so there's my decimal multiplier of 30%. And I'm going to go in the opposite direction. So I'm going to divide by 30%. And when I do that, the original price was going to be, that's going to be 200 divided by 30%. We get $666. $666.67. Okay, so that's going to be the original price. So the sale price must have been $467.67. So this is my original. That's the original price is equal to $666.67. The sale price was $446.67 because we can take that off. Now, I want to see if we should really be able to do it like this. Okay, so remember that percentages we can compare percentages directly in a ratio. So what we actually paid, the sale price, the actual sale price was, let's do this in a different color here, sale price was 70%. Okay, the sale price is actually 70% of the total. And we can compare the discount to the sale price. And the discount was $200, okay, in dollars. So dollars, and we're going to compare it to the X would then represent the dollars of my discount. Okay, so in this case, the multiplier is kind of awkward. Okay, so if I do my 30 divided by 7, 70 is going to give me 0.0428. So I'm just going to round that to 0.043. And so I can divide by that same multiplier, 0.43. Okay, so 200 divided by 0.43, we get the x directly as 466.67. Okay, so just a reminder that if we can compare percentages directly in a ratio, because the percentages are all about times and divide. This ratio comparison is also about times and divide. So it's important that we understand that these things are compatible and they go together. Okay, and so although we could have just subtracted here, understand that we can compare proportions in a ratio, and it's perfectly consistent mathematics because ratios are times and divide, percentages are times and divide, so we're not mixing up a whole bunch of different operations, we're just doing a times and divide comparison here.